They gotta never settle. This view is so much better. I'm chilling, I'm winning, like on another level. Oh, you can talk all you want. See me, I see prayed up, nothing I'm afraid of, and I can have it all. 5, 4, 3, 2, 1, go. Level up, level up, level up, level up. Level up, level up, level up, level up. All this on me so yummy, all this sauce so yummy. No, you won't just yummy, yummy all in your tummy. Level up, level up, level up, level up, level up, level. Level up, level up, level up, level up. Oh, so yummy. No, you want this yummy, yummy all in your tummy. They freeze, get drop like weight. Team Love don't want no hate. I'm grinding, I'm shining, up, up, I'm on my way. They gotta never settle. This view is so much better. I'm chilling, I'm winning, like on another level. Oh, you can talk all you want. See me, I see prayed up, nothing I'm afraid of, and I can have it all. 5, 4, 3, 2, 1, go. Level up, 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 level up. All this on me so yummy, all this sauce so yummy. No, you want this yummy, yummy all in your tummy. All this sounds so level, on another level. Elevate your level, level. Graduate your level, there's no one on it. Nah, nah, nah. Hey, level up, 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 level up. All this on me so yummy, all this sauce so yummy. No, you want this yummy, yummy all in your tummy. Level up, 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 level up. All this on me so yummy, all this sauce so yummy. No, you want this yummy, yummy all in your tummy. Level up, 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 level up. All this on me so yummy, all this sauce so yummy. No, you want this yummy, yummy all in your tummy.
Welcome, welcome everyone. It's another beautiful day. It's that June 2026 on a Wednesday, and we are happy to have you here. Welcome to yet another PPL session. Today we are going to learn about natural language processing, that is NLP, and we hope you all are happy to be in this place and into this space. Yes, I can see Juliet saying good afternoon to everyone. That is great. Good afternoon and good evening, and also I don't think there is anywhere that it's morning in the African time zone. Is there any place? I don't think so. So it's a good day. It's a great time for everyone to be here. Today we are going to have our host, who is one of the best data scientists and technical mentor that we have. That is Buhari Shehu. We are happy and pleased to have you here. So even as we invite him, let us first of all go through the rules of engagement. If you have any questions, post them on the Q&A section. Feel free to use the chat liberally and respectively. Last but not least, listen, learn, and engage. So we are very much happy to be here and happy to host you people. And let us dive into the main session. Today we have a lot of things to cover, so we don't want to waste any more time. Welcome, Mr. Buhari. We are happy to have you here. Thank you. Karibu sana.
Thank you. Karibu. So what should be the response? All right.
Asante.
But Karibu Santi. Okay.
Karibu means welcome, and now you're supposed to just say thank you. Asante is thank you.
That there is Asante Sana. All right. All right. Yes, and I'm even happy that we have this like a conversation with you, John. Why? Because today we are going to talk about languages. So Karibu is another language, English is another language, your language is another language, right? So how do we all make computer understand that? That is what we are after today. Please confirm, am I on the call? Because I'm
You're audible.
seeing my, because we want to learn about how computer understand languages. Let's have, how do you understand by this sentence? All right, I want you to help me in the chat. The man saw the woman with the telescope. So what do you understand by this? The man saw the woman with the telescope. So now the question is it the does the man use, did the man use a telescope to see the woman, or
Buhari, you are frozen. Yeah, he is coming back. Don't worry about that. We are sorry about that. Let's give him a few minutes. Kayode Adam, hello to you. Welcome to the PPL session. We're happy to have you here. Yeah, Juliet is saying you're not hearing anything. Yeah, we are working on that. Buhari is going to be back in a few. Just give him some few minutes. All is going to be back while. Yes, and here he is.
all right? I don't know why these guys want to be testing my patience.
The
All right,
village people are overworking.
I think we will need to find permanent solution to those guys. All right. All right. Thank you, Mike. Mike. So the question is, when you see this word, what the man saw the woman with the telescope, is it that the man used telescope? I mean, is it that the man used telescope to see the woman? That is one. Or the man saw a woman carrying a telescope. Which one, A or B? Oh, Kayode. It is also nice interacting with you, Kayode, and also learning from you. Okay, so it seems we're having different opinions. One, Teresa is saying B, Pusileso is saying A, then Adil is saying hard to tell. Mike is saying B, Hendrix is saying A. Okay. Kayode is saying it can be both ways. Okay. So let's go for the next one. Now, the next question is saying, the next sentence is saying, John saw Jane driving down the street. John saw Jane driving down the street. So is it that John saw Jane that is driving down the street, or John saw Jane while driving down the street? Which one? Which one is the correct one? A or B? Couple of A's. Okay. Anyone with B? Okay, that's interesting. Okay. So let's go for the next one. She served the data analyst with the fish. She served the data analyst with the fish. So A, she served, so a lady served the data analyst with the fish. Or which is the second meaning that we can derive from here? I don't even seem to see the second meaning. But maybe there are 2 meanings attached to this. Now, but nonetheless, okay, let me see the chart because I also learned from you. Adil is saying B because of the D. Okay, let's see. She served the data analyst with the fish. Still trying to wrap my head around this, but okay, data analyst with a fish. Okay. So let's go for the next one. The fisherman went to the bank. The fisherman went to the bank. So which bank? Is it a river bank or financial bank? Which one? River bank A, financial bank B. Which one? Juliet is a river bank. Which one again? River, okay. Kaide is saying indeterminate. Okay, Teresa is saying financial one. Okay. All right. So then okay, let's see the next one. This one is saying a woman without her man is nothing. A woman without her man is nothing. Then we have the second sentence. It is saying a woman without her man is nothing. Are they carrying the same meaning? Yes or no? Okay, Jen is saying no. Kaide is saying no. Okay. Is there anybody that is going to say yes? Okay. So you see, you can see how just using commas or using punctuation marks, you can change meaning, right? All right. Let me see. Is there anybody saying no? Are they saying the old version of NLP used to have this problem, not figuring out which is? Okay. All right. John is saying this can bring debate. Okay. Okay, my next one, the final one. Don't stop believing versus don't stop believing. So are they the same? Yes or no? Okay, Juliet is saying no. Yes. Okay. All right. All right. All right. So for the last one, if you are to choose, are you going to choose A or B? This one. Are you going to choose A or B for your own? So are you going to choose this? Oh, what happened? Or this? Which one? Oh, nobody is choosing B. Okay. Nice one. I think everybody will side with A because don't stop believing, and don't stop believing that you will graduate from machine learning. Exactly. All right. So why am I bringing this? Well, in the first case, this is the kind of problem which we have in language that we call ambiguity, right? So ambiguity is a situation whereby you have one sentence that can carry two or more meanings, all right? And this second one is also going to show us that the way you use your punctuation, the way you present your sentence can make the difference, right? And this is even in the case of written text. So what about in the case of spoken words? So sometimes the way you speak will determine the meaning that can be inferred. And sometimes human communication, that used to say like 70% of it used to come from the nonverbal cues. That's the body language, right? So the way somebody is talking will help you to deduce the meaning from it. Now, the challenge is if we as humans, we can be confused in some of these languages, how can we translate this to computer? How can we translate this so that computer understand these meanings? So you see, that's one challenge. Then two, when it comes to intonation or the body language, how can we impart this body language to computers? So you see, this is another challenge. Then human communication also has a lot to do with what we call context. So now how do we teach the computer context so that computer can also communicate with us the way we are communicating with one another? So these are numerous challenges that natural language processing try to address. Now, as some of you have mentioned that initially, all the olden days version of NLP, they are problematic because they are rule-based, but we are lucky today, we're having more intelligent NLP. Why? Because we are using what we call neural networks, which are more intelligent than rule-based NLP, right? And that's what give birth to the that's what brought up the advent of ChatGPT and the rest of that. So what do we want to learn today? We want to learn some basic concepts of NLP, not all of them. And we also want to use those basic concepts to build NLP projects, right? All right. If you are excited up to this point, please give me a thumbs up. But if you are not, I don't know, is there a thumbs down that you can give so that we can increase your excitement? Oh, I'm even saying you should give me a thumbs up. Maybe I cannot even see the thumbs up because I'm on presentation mode. All right, so now we'll go ahead with our demo. All right. Okay, yes, I can see the thumbs up. Thank you. Thank you. All right. So what is natural language processing? It is a field of AI, and the focus is enabling computers to understand, interpret, generate, and respond to human language in a meaningful way. So NLP tries to do so many things. One, enable computer to understand. For example, if you ask Siri to turn on your light in your room, okay, Siri is for MacBook. Okay, like if you ask Alexa to turn on the light in your room, Alexa should be able to understand that, right? Or to open your windows, Alexa should be able to understand that. So that is understanding. One, interpretation. So part of the understanding, that's interpretation, right? So when you speak, it understand and it can be able to interpret. Okay, after understanding, okay, it can interpret and maybe give signal to the motors that are going to open the windows or the rest of that. Not only that, we want NLP to generate, right? I don't need a lot of English on this. We all use ChatGPT to generate text, or we use other models to generate images, videos, and the rest of that. And not only that, respond to human language in a meaningful way. So sometimes you can have one-on-one conversation with maybe Gemini, for example, through the Gemini app. So you can be talking with Gemini and Gemini will be giving you answers, just as you used to have conversation with one another. So all these are what we want to embed in computer, right? So the goal of NLP is to bridge the gap between how humans communicate and what computers can process. It involves both written text and spoken words. So the written text and the spoken words, for example, nowadays you can speak to computer and computer can give you answer. For example, if I say, hey Siri, Siri may be able to respond. Okay, maybe maybe because I am on Zoom. That's why this Siri refused to talk. But usually Siri can talk, right? Or when you say, hey, Google, your phone should be able to respond. All right. Now, in the field of NLP, remember we say we are dealing with language, right? So because we are dealing with language, NLP will combine what we call linguistics. That's the study of grammar, meaning, and structure. Then it will also combine this with algorithms and data structures, right? Not only that, it will combine this with what we call machine learning models. For example, like the transformer models and the rest of that. All right, so let me, off the top of your head, can you give us some applications of NLP? Let me see in the chat, please. So I'm in the chat waiting. Can you give us some applications of NLP? Alexa, okay, what can Alexa do? Adil is saying search engines. Okay, good one. ChatGPT, okay, what can ChatGPT do? Okay, anyone? Virtual assistants, chatbots, okay. All these ones, they are example of applications that employ NLP. So what can the NLP do to you as human? Okay, Jessica is saying we can use it for fraud detection. Okay, good one. Kaide is saying use in determining customer reviews. Thank you very much. So for example, you as a company, you can use NLP to examine or to analyze what your customers are saying, right? Because the success of your business depends on what your customers are saying, right? Like Hendrix is saying textual data analysis, okay. Adis is also saying sentiment analysis. That's very good. I like it. All right. So some of the applications of NLP, one is machine translation. For example, right at the opening, we are discussing with John where he was saying Asante Sana, and I was confused as to what will be. What did he even say? I hope I've said the right thing. I know he was saying Karibu Sana. Off the top of my head, I know of that Asante Sana because of that song. All right. So you see, now, for example, if I'm in Kenya and I don't know Swahili, so I can use my phone to translate. Like when he was saying Karibu Sana, I can just ask Google Translate to translate that for me, or I can use any translation machine to achieve that. An example of this is Google Translate, right? So with this, for example, like nowadays, again, if I may ask, which type of movies do you want? Because like me personally, I like sometimes Korean movies. So for example, how about if that Korean movies, there is one application that once you pass the video, it can just translate it to your language. That would be a good one, right? So with machine translation, you can have the world as a global village. Oh, let me see some of the response. Okay. Then sentiment analysis, as some of you said. So this one is used to detect the emotion or opinions in text. For example, if you are a politician, sometimes even before the polls, politicians can use this to evaluate the opinions of people. For example, based on the charts or based on the post on social media. So you can scrape that data. Then you can scrape the emotion of the people about one particular candidate. So from there, sometimes you may be able to determine whether that candidate may win the result. I mean, may win the election or not, right? So if you are a company, you can scrape the, for example, if you collect feedback from your customers, you can use this sentiment analysis to determine how your customers are finding your product, because if your customers are happy, it means your revenue or your bank account will also be happy. But if majority of your customers are sad, it means your business or your bank account will be sad, right? So like there's okay, I think it's cohort 9. Yes, cohort 9. So there is one lady that built a project that she analyzed the reviews of banks in Ethiopia, right? So different banks. So from there, she can say, okay, this bank is doing well, this bank is not doing well. Maybe she can even approach some banks and tell them that, okay, look, you need to fix this, this, and this in your bank in order to succeed. All right, another one is chatbots. I don't need to tell you about ChatGPT and virtual assistants like Siri and Alexa, right? Then we also have text classification. This one like spam detection. So for example, spam, who can tell me the disadvantage of spam? Spam email or spam messages, who can tell me their disadvantages? Anyone? Teresia is saying flood the inbox. Some are fraud. So when they flood your inbox, what is the implication of that? Exactly. Adil also went further to explain that it caused a lot of distraction and waste of time. Exactly. Time is very precious. Imagine somebody somewhere else will be wasting your time just because of spam, right? That is from your own perspective. Then from the perspective of the company offering you email services, they stand the chance of losing customers. So for example, like I use WhatsApp quite short, but sometimes you see some groups, 1,000 messages, 2,000 messages. I don't have time to check that. So over time, people will be saturated with all this and they may stop using the application altogether. So it means the business might lose some customers. All right. So that waste of time is very big problem. And so that's why we need to detect spam. Or sometimes like topic labeling. So for example, in the case of newspapers, when you are a big news company like CNN or BBC that used to generate news across the globe. So the rate of news, the rate at which news is generated is high, right? So you saying that you will manually classify all news articles, that will be challenging. So you can use machine learning or NLP to help you achieve that, where you say, okay, all news related to sports, go one side. Those related to health, go another side. Those related to politics, go another side. Science and fiction, go the other side, for example. So this will help the company to quickly classify their news and also to better support or serve their customers. All right. Because, for example, if you are not like even in sports, you have football, you have all those sports that we have, you have them. So even in sports, some people like one particular sport over the other, right? So even in that, how do you classify them? So in order to achieve that, what you can use what we call topic labeling, right? Then we also have what we call name entity recognition, where you try to find names from an article. Then we also have speech recognition. We have text summarization. So for example, you have lengthy text. How can you summarize it so that you can get the essence in a short period of time. Text summarization can help you with that. Or suppose you have a lot of customer reviews and you want to summarize them so that you can quickly get what your customers are saying. Text summarization can help you with that. Then we can also have question answering. So for example, like here at ALX, we have Fresh Decks, and in the new rollout of this program, you will have Chidi. So Chidi is a learning assistant that can help you to learn. So all these are NLP systems that can help you with this, right? So for example, immediately you ask question, those chatbots can easily give you answers. Information extractions. And for example, autocomplete, autocorrect recommendation systems, document search and retrieval. For example, search engines, they use this one. Text to speech, TTS. Who can give us, okay, for the purpose of time, let's just continue. So this text to speech, for example, like people with disability, they can use this text to speech to what? To read text on screen for them, right? Let me just give you an example of this. Where is it? For example, if I go to reading mode, so you can see my screen, when I say read.
Copyright 2026 ALX. Outcome. Outline. What is natural
language processing?
Stop. Can you hear the words? In the chat, please help me, yes or no? Okay. So you see, this is an example of text to speech. Oh, I even forget to share the link with you. For those of you that want to follow along. All right. So you see, this text to speech is already embedded in your Chrome browser, right? So if you have somebody that is having that cannot be able to see, he can use text to speech in order to understand what is going on there. We also have plagiarism detection, most especially for those that are publishing articles, and we also have social media monitoring and topic modeling, just as we mentioned. Then my next question is, what are the disadvantages or side effects of NLP to society? Can somebody help us in the chat? I am waiting. Is NLP having any side effects to the society? Remember, NLP is language. That's disadvantages or negative effects or adverse effects, whichever English do you want to use. Anyone? Okay. So negative effects, one, we have privacy concerns. Like some NLP systems often require large data set, including personal messages. For example, your email spam detector, you have your personal messages there. So imagine Google will have to be reading your personal messages. That is privacy issue there, right? Conversations. So for example, like even in this call, you may have some chat bots that are recording the call for some of you that may not be present. So that those chatbots, the companies that are providing those services, it means they have the ability to listen to many conversations that maybe some conversation can be sensitive, right? So that's infringing on some people's privacy, right? Now, another one is bias and discrimination. So this bias Victory is ambiguity. Our language is filled with ambiguity. Exactly. As the saying goes, people don't say what they mean, and they don't mean what they say. So sometimes when people, for example, like in my language, sometimes when you are doing something, for example, when children are doing something and their parents don't want it, so instead of the parent to tell them stop it, they will say continue. So from the intonation, the child will know that, okay, it means you should stop. Meanwhile, the parents are telling him continue, meaning the parents don't mean what they say. And you know, they are 5 and 6, right? So if they say continue and you decide to continue, you will know the consequence. When, most especially if slippers is nearby, right? And sometimes we don't mean what we say. So, and we say model can learn bias and discrimination. All right, so bias and discrimination. So because the world data is biased, and we use this data to train these models, it means the model can also be biased. So let's have an example of this bias that we are talking about. So let's go to Gemini.com. So when we come to Gemini, we can come to, not this one. Okay, you can come to create image, right? So this create image, if I say generate image of people in the market. So this will naturally take time, but when it finish, we'll see the people that it generates. Let's have another one, Gemini. So this one, we can say create image, generate the picture of a slave. So can we see the image that Gemini generates for us? What can we say about this image in the chat? All right, anyone? Am I on the call? What can you say about this image that is generated? Guy, there is an app description of a marketplace. Okay. Exactly. Hendrix is saying ethnicity. So looking at this image, how many Black people can you see here? Should I zoom this? Oh, zooming is going back. Okay, let me do it. So it means I cannot zoom. Okay, is there any Black person here? Oh, Terecha is in most our religion. Okay. That's another one. And we also cannot see Black people here, right? All right. So you see, this is bias. Why can't we see black people here. That's bias, right? But let's go to image. Oh, I think Gemini have already upgraded. They say, when I say generate picture of a slave, they say that is powerful, sensitive topic. So we want to be really thoughtful about how to approach it. There isn't really a single image that could represent. So I think now Gemini are already putting in the guardrails, right? As these models are constantly improving. So this is a good one. But let's take it further and say generate a picture of a computer expert. All right. So these are some of the biases that are available there. Misinterpretation of language. So sometimes, most especially, you may give a command to NLP and it may misbehave, right? That is one. Then also, when you give it translation tags, it can also misbehave. All right. Oh, so you see, when we say generate picture of computer professional, a black man was generated. Why not white man? And is it because of this? Because of this, that's why we are having this as a black man. All right. So you see, that is the bias we're talking about. There's a lot of that, right? So misinterpretation of language. You can imagine when computer misinterpret. For example, if you give translation tags to computer, sometimes this NLP, they can do good job, but sometimes they can make mistakes. So we all need human judgment. Job displacement, yes. This NLP can create job displacement. So job displacement, sometimes I would like to look at it from the perspective of changing the job description for us. So why am I saying this? So for example, for example, like computers can translate text, right? So because they can do that, does that mean when they translate, you should just take everything and present as the correct thing? No. You will still need humans to review what the computer have translated. So now, instead of the human being the translator, the human will now be the reviewer, right? So in this case, it is changing the job description for this. All right. But maybe to some extent, sometimes like the way we generate adverts, sometimes we may not need humans to generate advert for us. For example, if we give it to this NLP. So in that case, maybe that would be a job loss. But there's also redefinition of some jobs. Misinformation and fake content. So before NLP, one of the signs of knowing fake or fraudulent messages is through the spelling, right? So maybe when you see grammatical errors or spelling mistakes, you'll know that, okay, these ones, they are not serious, right? But nowadays, the fraudsters, they have already also upped their game. Now they will use NLP to generate their content, trying to trick vulnerables, right? Now, another one is over-reliance on technology, most especially learning. So for example, as a learner, sometimes some learners may outsource their learning to NLP, like to LLMs, like ChatGPT and the rest of that. So if that happens, what happens to critical thinking? So now when the danger with you delegating your learning to that, one, you may not get the chance to learn. That is one. Two, these NLP or these models, they can do what we call hallucination. So this hallucination means they will present something that is wrong, but they will be present it with confidence, with 100% confidence that it is the right thing. And if you don't have the expertise, you may accept it as the right thing. And sometimes this can be dangerous, most especially if you are talking about financial or health applications, where small mistake can lead to great financial or biological loss. So in that case, this over-reliance is is a key issue, right? So the way I want you to use this, for example, you learn all the things that you are supposed to learn. Then if there's anything that you don't understand, then you ask the model to clarify it or simplify it for you, all right? For example, like cloud code. Cloud code can generate software for you, but if you don't have the knowledge of software engineering, you'll not be able to ask cloud code the right questions to generate the software for you. That is one. Two, cloud code can generate software for you. How about when the code is getting old? As the code is getting old, many of these packages, they are going to be updated and errors are bound to happen. So if you don't have the knowledge of software engineering, you'll not be able to troubleshoot those errors that are going to come as a result of, in the future, right? So then we also have security risks, high resource consumption, cultural and linguistic limitation. There are many. Now, some common terms that we used to learn, we learn when we are learning NLP. One of them is a token, right? So what is a token? A token, how do we, for example, if I give you a novel, how do you understand what is in the novel? Do you just look at everything at once and everything is part of you? Or how do you do that? Do you read the whole pages at once, or you read pages one by one, and in pages word one by one? Okay, Victory is saying by then AI can troubleshoot very well. Yes, I agree with you that AI can troubleshoot. And even now, as we speak, Cloud Code can troubleshoot your code for you, right? But the problem is, if you don't have the knowledge of software engineering, you will not know the right questions to ask Cloud Code to troubleshoot for you. That's the problem. And also, there are so many decisions that you need to make. For example, imagine Facebook, where they have billions of users. Also, one of the problems is speed. So how can you access Facebook fast? That's one problem. So if you just delegate that to just Cloud Code, you may not be able to achieve what you want. So we still need a human in the loop to make the decisions, right? But before you can be able to make the decision, you need to understand the game. All right. But Victory, if you have any counter opinion, you can also bring it. We are open to learn. But yes. So how do you understand long passage? You'll understand it word by word, right? So similarly, when it comes to computer will understand long passages word by word. And word in computer terminology or in NLP terminology, we call it token, right? So token is a basic unit of a text that an NLP system processes. So we are saying it is a unit. So sometimes the unit can be even smaller than a word. One, sometimes it can be a word, sometimes it can be a sentence, or it can be a phrase. So all these ones, they are tokens, right? And as a matter of fact, if you are using API of ChatGPT, they sell that API, they sell the service in terms of the number of tokens that you use. That is one. Then two, we have what we call a document. So what is a document? This is any piece of text, like a sentence, a paragraph, article, email, or customer review that we use, that the system treats as a single unit for processing and analysis, all right? So while the token is the basic unit, but when it comes to the system-wide analysis, to carry out the whole analysis, we talk of documents. So think of it as, think of a token as, for example, in a table of data, let's say the table of data in a column of age. So the first row, you may have age 2. The second one, you may have age 20. The third one, you may have age 30. So that age 2, that is like a token when it comes to NLP. Now, when you take, no, this one may not be the right one. Okay, the right explanation might be this table right down here. So having this table, this trend is a token, this language is a token, this models is a token, right? Now, when we are talking about documents, the whole of this, that's one document, all right? Then corpus, when we say corpus, the whole of this column, the whole of the column use case, that is a corpus, right? So when you are doing your machine learning, when you are doing your machine learning training, you usually pass the whole column for it to either determine the sentiment or the rest of that. All right. Does that make sense? Oh, so should I take? Oh, okay. Thank you for the response. You know, we as humans, our language can be complicated. Like silence, we used to say silence means approval, right? So in terms of NLP, when you are silent, you mean nothing. But to humans, when you are silent, we mean you are approving. So that's why when you see injustice, don't keep mute. That's if you can talk. So judge the situation. If you can talk, talk. But if you talk and the consequence is is grave, so don't talk, just keep quiet. But in your mind, you know that they are not doing the right thing, right? So this corpus, we use them in training machine learning models. So for example, like in school, if you want to learn law, you are going to read law textbooks, right? So those law textbooks, when you have a lot of them, for example, if you go to a library section, to a library, there is section for law. So if you take the whole textbooks that are related to law, the whole of them, you can call them as corpus, right? So if you want your NLP to be expert in law, you pass all those textbooks, all those texts related to law, you pass them to the model for the model to learn, all right? So once the model finished training, then it can now be able to answer problems or to solve problems related to law for you. So the whole collection of those books, they are regarded to as corpus or corpora. So we are lucky enough that there are some open corpora for us to use in training our models. One, we have they are even of different types, like the general language corpus. For example, like the Wikipedia dumps, the news articles, all these ones, you can use them to train your machine learning models. So that's what ChatGPT does. So they scrape the entire websites of the world. Then they use that to train their model. Now we can use it to generate a lot of different variety of text. Then we also have speech corpus. So this one, you have a lot of recordings, a lot of audio recordings and audio transcripts that you can use for this purpose. Use case of this is speech recognition. Then even in text, you have some text that they are called tweets. So that's why we have the tweet corpus, and we can use this for sentiment analysis. So here I link one of the tweets corpus for us to see. So like, look at the data here. So you see the document, the number of documents that we're having, we have 9,551. The number of tokens, that's the number of words. They are what? They are this. The entities, the location, that's the person entities, the number of names, they are this. Number of places, they are this. Number of organizations, they are this. In this data sets alone. And so if you like, you can explore the data set, it is there. And so going by this, let me see those of you that are following. How many rows are there in this data set? Can somebody tell us in the chat? How many rows are there in this Twitter corpus? Adibwale is saying 5. Okay. Anyone? 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 Okay, the number of rows. Kaide is also saying 5. Nice try. So in this data, remember this is, I know many of you are looking at this. So this is metadata. That's the data about the data. So what this is telling you that looking at this, you have 9,551. So this data is having 9,551 rows because we say document. A document is one row. You remember? Yes, thank you, Adebo, for spotting that. Thank you. All right. So that's Twitter data set for you. We also have the legal corpus and rest of that. Now, enough of the background. Let's dive into the project. So next up, what is regular expression? So before you can apply your model, first of all, you need to process your data. You need to pre-process your data, right? Why do we need to pre-process our data? One, your data may have spelling mistakes. It may have grammatical errors. It may have different punctuations and so many other complications that when you feed it as it is, the computer may be confused. One, or two, the computer may give you wrong analysis or wrong insights, right? That is why we need to pre-process our data. And whenever you have text, because one part of language is text, whenever you have text, then there's one powerful package called regex or regular expression that you can use in order to pre-process the data. So regular expression is a powerful pattern matching language used to, one, you can use it to search, two, you can use it to extract, and three, you can use it to manipulate text. So for example, sometimes when you are given a text, the task will be to search for a particular word. Sometimes it's not only to search, it's to extract some particular information, right? So for example, given a text, let me give you an example of this. When you apply for a job, that's what they call ATS, that's applicant tracker or tracking system, right? So sometimes, because LinkedIn have easy apply, so the companies or the recruiters also have easy select. So their easy select is the ATS. So what they use ATS for? Normally when you are applying for a job, you are supposed to read the description of the job. Then you are supposed to prepare a CV so that it can answer the requirements of the job. So whenever you submit your CV, the ATS is already, what is it called? The job description is already fed to the ATS. Then the ATS will be, you'll be instructed to find all those CVs that are more relevant to this job description. So that's how they do their screening or this. That's the first round of screening. You pass through ATS. Then the second round, you pass through maybe human interviewer or recruiter. Although this may be biased, one, because sometimes CV may not fully model your experience, but that's the world we live in nowadays. So in this case, in the case of ATS, it is to extract meaningful information from your CV, for example, and manipulate text. So sometimes when your text is in all caps, how do we make it smaller caps? We can use regex for that. Now it allows you to define patterns that can, you all know that definition. All right, so, but what I want you to take note of, there's what we call regex functions, right? So the regex functions will start with RE. So this RE is the alias for regex that we are going to import. That is one. Then two, this is the function name. Then, and we call it a method. Then you pass the pattern that you want to search. And where are you going to search that pattern? The string. That's where you pass it. Sometimes you may have flags for more granular searching, right? All right. So we'll explain this with examples shortly. Now, before we dive into the examples, sometimes, for example, this is a list of some functions that you can use for regex. For example, like re.search, this is a function. And what can you use it for? Find the first match anywhere in the string. You can also have re.match, re.fullmatch, re.findAll. So we'll experiment with some of these functions. All right, so this is the function. Now, when you come to regex, there's also what we call patterns, right? So the patterns, the simplest pattern is you get a word and you pass it to the function. That's the simplest one. But real world examples, you go more than that, or you pass that. So we say some of the patterns that you can have, for example, literal characters like cat. For example, you just get this word and you say, find wherever you see cat in this document. That's one, but most of the time we use the specialized ones like the character class, like when you have /D, it means what? Digits. Find any digit in this text if you are using the find function. When you have D, capital D, that's non-digit. So small d is for digits. When you go to capital D, it means you should find the opposite of small d, that's non-digit. So you have W, which is a word character. So when you take the capital of W, non-word character, right? So S, white space. When you take capital S, non-white space. So small letters for the actual thing, then big letters for the opposite of that. Now, when you see /, if you just pass D, it is going to take it as literal character. But this special symbol, /D, it is telling regex that this is going to be special. You shouldn't treat it as a small d. All right. So the patterns can be much. You can find many of them here. This is the list I compiled for you. Oh, Juliet is saying, share the link, and thank you, Adebowale, for helping me in that regard. All right. So now to use regex, first of all, we import RE. So regular expression is already shipped with Python. So you don't need to install anything, right? Now, suppose you have this text. My department, the text is, my department number is this. So suppose you have this as your department number. So how do you find digits? Remember, now the pattern for digits, if you have this D, let's remove the plus. So the pattern for digits. So to write the pattern, you say R, then you put it inside commas, inverted commas. And so this is your pattern now. All right. So remember, we said our syntax is what? First of all, we want to find. So we use the function called search. What do we want to find? We want to find digits. So instead of us to be writing different numbers here that we want to find, we just pass the pattern of numbers that we want to find. And where do we want to find it? We want to find it in this particular text. So this is the string, right? So everything here will be assigned to a what? To a result variable. So when you do that, you get this, and now you can print your output. You see, what can you see here? You see, you are only seeing 0, which means when you say D, it means regex is finding only one digit. That's what 1D means. So how about if we say double D? Let's see what will happen when we increase that. Oh, double D will not work. Okay. So, but if you want to find phone numbers, I think you want to find all of this. So in order to do that, what are you? Okay, let's do it another way again. / another D. Let's see what will happen. Our results, okay. So you see, if you want to extract 2 digits, you put another D again. You want to extract 3 digits, you put another /D. But you believe with me that this one will not make much sense. So in order to find the whole number, we put what we call plus. All right, so when you put plus, you say this, and you see now it is extracting everything for you. All right. So that's that about finding digits. What about finding text? So remember, if you have hello, and to find text, we can use match or search, all right? So we can use match or search. What is the difference between the two? We'll find out shortly. So if you have match, so the pattern that we want to find, here we are we are just passing the text, hello, and we're passing it in this text. All right. So you see we are finding the hello. All right. And so that's in the case of match. Now let's try search again to see what will happen. You see search and match are giving you the same result, hello. Okay, so how do they differ? Now let's change something. Let's put A before the hello. No, not this, not here. In the text. So you see, when there's nothing when the what you are finding is not at the beginning, Python will raise attribute error, right? But let's see if we pass the same to this, to search, what will happen. You see, to search has no any problem with that. So in the case of match, it has to be at the beginning. But in the case of search, it can be anywhere. All right. So that's the difference between match and search. Then the next one is search, the difference between search and find all. Okay. So here, remember to find all digits, we say D plus, of course, preceded by slash. And now let's put search. All right, so in the case of search, what do we have here? We need to pass the group in order to see what is there. So in the case of search, we see it is finding the first number and nothing more. It is not finding 5, it is not finding 12. But if you want to find everything, you need to find all. So search is finding the first occurrence, whereas find all is going to extract everything for you, right? Then substitute text with text. So for example, I love Python. Python is great. If you want to replace Python with JavaScript, how do you do that? You can use the sub function. All right. So what do we want to replace? We want to replace Python with JavaScript. Remember, in all those word editors like Google Doc and Microsoft Word, where you do your find and replace, that find and replace was implemented using this, right? Using this kind of function called the sub. So when you do this, you see, instead of I love Python, Python is great, we are now having I love JavaScript, JavaScript is great. All right. Or let me do it this way. I love C9 ML, that's cohort 9. Cohort 9 ML. Then cohort 9 ML is great. So if I like, I can replace cohort 9 with cohort 10. That I even like, so I'm going to replace. I love cohort 10 ML. Cohort 10 ML is great. Or let me make it more human. I love learners. Are Great. Okay, I think that will work. I love cohort 10 ML learners. Cohort 10 ML learners are great. All right. So that's that about a regular expression, but there are a lot of things that you can do with it. This is just the introduction. Now, part of the things that you do in pre-processing your text is text cleaning. In your text, you might want to remove unwanted words. Some words, they can be irrelevant. Some words, they can be noisy, right? From your raw text. So how do you do that? One of the issues that we can face when it comes to text is casing. So, in English, you may have uppercase, not you may have, you have uppercase and you have lowercase. For example, we know that to start a sentence, you start with capital letter. Then subsequently, you follow it by small letters. To start a name, a proper name, you start with capital letter. So if you apply the same to NLP, NLP will consider that capital letter text different from small letter text, right? So in order not to confuse NLP, how do we ensure that all the casing of the text is uniform so that the machine will not be confused much? Then removing punctuation. So punctuation, we have seen how punctuation can change meaning, but if you pass punctuation to machines, they may be confused further, right? Eliminating extra space or line breaks. So you may have text where when you are typing, you may give more than one space. How can we eliminate that? Or sometimes the extra space can be a trailing space. That's the space that comes at the end of the word. So if you don't eliminate that, when you come to analysis, that particular word will be different from the one that is not having that extra space. Removing stop words. So some words like the, and, is, and the rest of that, they add meaning in English, but to machine, the meaning they add is very little. We will see some tags where stop word removal is essential. Although we say stop word removal is essential, there are some tags that you don't remove the stop words. So the tags at hand will determine whether you need to carry out some of this pre-processing or cleaning steps. Correcting spelling errors. Yes. So we are humans. Sometimes we can make mistakes when we are spelling things, right? So when you have text with spelling mistakes, how do you correct that? Normalizing text by expanding contractions like don't. How do you expand it to do not? So nowadays we have emojis when we are communicating. Like some of you are communicating with thumbs up on this call. So how do we interpret that? Or how do we handle that when we want to pre-process our text? Now, the document that we want to use for this is this text. So I copy the text from the internet and I present it here so that we will see the text we are working with, not that import this, import that. So this is the text. If you want to see the text, you can click this link. I hope it is still available. It is BBC News article. Okay. Oh, shit. I have I've exposed some things that I want you to answer, but nonetheless, we can move ahead. So this is our document. All right. So one of the things that we can do in machine learning is called topic modeling, right? Now, when you read this text, who can tell me what wisdom can you apply to quickly determine what this text or what this passage is all about? Can somebody help us in the chat? What wisdom can you apply to this to know what this text is all about? Adebowale is saying summarize the text. Okay, I like that. What again? Adil is saying AI. Okay. Adil, I want you as human. We have a situation whereby you are reading, right? For example, when you have this notebook, you are reading it. How do you determine what this text is all about? So in the title, okay, Adil, here there is no title. So how do you go about that? First paragraph, yes, exactly. So the way we structure our text, sometimes you can read the introduction, you may be able to get that. And sometimes you can read the first sentence in a paragraph. The first sentence in a paragraph is called the topic sentence. Sometimes the topic sentence comes at the middle, sometimes it comes at the end. All right. So all these are ways of getting the topic of a given passage. One. Now, however, there is another way. And let me ask you. For example, if I tabulate all words in this document, and then I count all their occurrences. For example, this word in one column, then I'll count how many D I have. You can see that Google Color have even helped me to highlight them. So you can see you count them, then you go and write. Then you come to bank. You count how many you have, you go and write their number. Then I say, okay, words, or I mean the word with the highest frequency is the word, is the title of the document. Do you agree with this wisdom? Okay, thank you, Adil. Okay, Adil say you agree. Yes, because you also mentioned the most common words, right? So let me have other responses. Do you agree with this wisdom? That the word with the highest, or the word with the highest frequency is the topic of the document or article. Do you agree with that? Anyone? All right, Victory. Oh, Victory is saying no. Okay. We shall see. Okay. So let's see. So this is one of the wisdom. Oh, it seems we have a lot of disagreement, but let's try this and see whether it will work. Yes, we have seen our opinions, so let's put our opinions to test. All right. So this is our document, and now we want to model the topic. So now how can we count the number of words? Each word here. Well, thank God we have what we call the collections. So the collections module, this is also shipped with Python. From there, we can import counter. So let me show you how collections work. So for example, you have your text. You have Apple, you have computer. Like Apple computer great. So this is my text. Now I want to find, what do I want to find? I want to find all words. All right. So this is the pattern to find all words. So W will find one character, but if you say W plus, you'll find different characters. So words, you can find words here. So let's see what is in words. So you see, this is a list of all words in this text, right? So now, how can we find their numbers, the number of apple in the text? We can use the counter to achieve that. So now we can see the frequency, we say counter, then we pass the words. So we can say we can see is appears twice, apple appears twice, that's small apple. Big apple appeared once, then computer once, and the rest of them once, right? So you see, you believe with me that this sentence is about apple, right? And we can see, although is having 2, but apple is also having the highest frequency, all right? So we see this sentence is about apple, and with just ordinary counting, we're able to locate that. Now, however, somebody will say this is. You see, this is, for example, let's look, when we look at this document, like the doc, words, we are now talking about this one. This is the small one, so we want to find all words in the docs. So let's count their frequency. We can see the word D is having the highest frequency. Then we have the off. Then we have the to. Then we have the in. So using our logic will fail when we say the word with the highest frequency, because that's not the topic of that. So, but then, what can we do? And you see, another issue here, this D that we're even talking about, the capital one here is having 13. So in this kind of case, in this kind of topic modeling, it doesn't matter whether it is capital or small letter. So that's why we need to convert everything to small letters. So when you convert everything to small letters, this will add up to this. And instead of 53 here, so you have 53 plus 13, that will become 66, right? So still in that case, D is having the highest frequency. And we may say that D is the topic. But in this kind of problem, that these words, they are preventing us from achieving our goal. So that's why we say, what in a situation if we drop all these things that are not useful in our topic modeling? So that is called, so these ones, they have special name given to them. We call them stop words, all right? So in this case, like in the case of topic modeling, you remove stop words. So when you remove stop words, like all of this, you see the next one that comes up is AI. See? Then even this said, well, this one is not part of it, but we can see bank is making part of it. So let's go back to the main, or to the article by BBC. That's to the main article by BBC to see what their topic is. Bank of England warns of AI bubble risk. You see, Bank of England, AI is here, bank is here. So it means this simple model have already done the work. So this is telling you that NLP, sometimes it doesn't have to be something complicated. By simple counting, you are able to achieve your objective of extracting the topic. All right, so so now let me come back to Hendrix, Kristen, and Juliet. Now, do you agree with me that word frequency can be used to identify the topic of the sentence or the topic of the article? Yes or no? Oh, Hendrix is saying yes now. Okay, I'm happy. What about Kristen? is it Christine? Yes, Christine and Juliet. Okay. All right. So that's topic modeling, one of the problems of the news websites. Oh, Juliet is still not clear to you. Okay, what is not clear to you? Mike agreed now. Oh, let me see what Victory is saying. In this case, D seems to be more, so you cannot determine that with it. Yes, Victory, that's why I say in NLP tax, there's what we call stop words. So this D falls under that category. So usually when you are doing topic modeling, you remove all stop words. So when you remove all stop words, all these ones will be gone. Where are they? No, all these ones will be gone, right? So the next one that will come is AI at the top. All right, so let me see the remainder of your response. Except it is a word that is not normal sentence, then we can start seeing it as a key to figure it out. Okay. I hope that clarify your question. Okay, Juliet is saying not clear to me. So Juliet, what we are saying, when you have a passage or an article and you count all the words in you extract unique words in that article, that is one. Then after you extract the unique words in the articles and you count the occurrence of each one of those words, then chances are that the words that are having the highest frequency are the topic of that article, right? So we say we went on to use the counter. So this regular expression find all will find all words in our document and present them as a list, right? So let me print the list for you to see. Words. So you see, this is list of all words in our document. Now we say the counter class will count how many times significantly come in this list, how many times added come in this list. And luckily for us, it will arrange them in descending order. So when you do that, you achieve this. So we say D comes 53 times, but these ones, they are obscuring the meaning. Because when you are talking about the topic, you don't talk about the article, you don't talk about the conjunction. You're only looking for words that are important. Then we say, okay, now when you look at AI, the next common word is AI. And this one, although this one is not may not be part of it, but the next common word is bank, right? So we say, if you look at the original where I copied the document from, you see here, Bank of England warns of AI bubble. So this one is telling you that this model of counting and extracting the most frequent is helping us achieve our topic modeling. That's extracting topic from a long passage, right? So remember we talk about stop words. So stop words, how do you extract stop word? We can extract them. First of all, we install NLTK. Then we import NLTK. So NLTK is Natural Language Toolkit, right? Then we download PuncTab. So after downloading that, then we import stop words. So let's see some stop words that are available in English, right? So here you even, for example, you say nltk.corpus, import stop words. nltk.tokenize, import word tokenize. Then we download Punc tokenizer, and we also download stop words. So once we download stop words, now stop words English stopwords are available in our, or stopwords in general are available in our working document. And from here, we can extract those stopwords that are available. We say text is equals to doc stopwords. Now we can say set stopwords, and the words we want, for example, stopword of English will be different from stopword of Swahili, and it will be different from stopword of Amharic and the rest of that. So because of that, that's why you need to specify the language here. We are looking for stopwords for English. So, and here, this one will print those stopwords. So you can see those words that we are talking about, like they, this, then, themselves, theirs, all these ones. When you're doing topic modeling, they shouldn't be there. All right. So these are stopwords. So for example, now you have your document, our original document doc, that we want to remove stopwords from. Regular expression will come in, right? Or you can use what we call list comprehension. So suppose we have words. First of all, we need to tokenize our text. So what is tokenization? Tokenization is breaking down your text into smaller words, just like what we did here with this regular expression. Where is it? Like here, this is the sentence or the document. Now, before we can process it, we need to break it down into words. So we use regular expression here to break it down into Apple, computer, is, and the rest of that, instead of one chunk of text. So from here, that's when we did our manual analysis and we passed the words to this. So if you just pass the text, let's pass, where is it? This text, let's pass it to this. Let's see what happens. You see, when you do this, what do you see? It is getting, what is it called? Alphabet by alphabet or letter by letter. That is how it is doing the counting. So that's why we need to tokenize. So this one, this regular expression is actually tokenizing. The tokenization is meaning breaking it down into small words, right? So now we say words. So instead of this, when we pass our words, so you see now we're having words instead of individual alphabets. So here also, this word tokenized, then we pass our text, is actually breaking it down into smaller words. Then when we do that, this is our words. Now we want to remove the stop words. So this list comprehension can help us to achieve that. And let me quickly unpack this. So this one is also doing another thing for us. What is that? It is converting everything to small case, right? So when it converts everything to small case, meaning whether it is, everything will now be small case, right? So, well, I know you know what we call list comprehension. So let me work on that assumption and we can proceed. But if you want me to come back to the explanation, then I will be happy to come back to that. So in essence, this one, not in stopwords, will remove all stopwords for us. W.lower will convert everything to small letters so that D that is starting with capital letter T and the one starting with small letter T will be counted as one. But if stopwords are ever removed, they will not be appearing. So this is our filtered words, and we pass them as a list. So when you get your list, now this is your list. We have the bank, the rest of that, and the rest of that. Now, from this, we can now do our find all. That's to still apply our what? Our counter model, right? So when you do that, now your words, because we have filtered out the stop words, now you can see AI is now having the highest frequency. Although this is not still perfect, but we are seeing SID, although this one is not part of the topic, but I mean, it's a good start, right? You can see bank, you can even see financial also. So this is telling you that this article is about financial, or using AI in financial institutions, right? Bank of England warns of AI bubble risk. All right. Now, as I said, it is not in all cases that you may need to remove stop words, but topic modeling is one of such cases that you may need to remove them. When to remove stop words, word frequency, topic modeling, text classification, clustering, search indexing. For example, when you are searching Google, when you are searching anything on Google, Google will ignore all these ones. So it will just look for the main words like with these words, like this top and the rest of that. So that's how search engine work. But in some instances, you may not need to remove stop words. One of such instances like name entity recognition, if you want to extract name entities like people's name, organization's name, then in that case, you don't need to remove stop words. For example, Bank of England, if you go and remove off, it will become Bank England, which is not the same thing with Bank of England. Or First Bank of Nigeria, for example, if you go and remove the off, the first and the bank, and the Nigeria will be there. The off will be gone, and that's not the entity. For example, somebody is saying, I am not happy. If you go and remove not, the meaning will change. I am happy. So when you are extracting the sentiment, instead of you to extract something negative, you are extracting something positive, which means in sentiment analysis, don't go and remove stop words, right? Machine translation. These stop words, they add meaning. For example, if you say the man and a man, they are different. So if you go and remove that, the meaning will change. So in machine translation, don't remove stop words. Text summarization, all of that, don't remove stop words. So you remove stop word with caution, right? Then another pre-processing is punctuation removal. So when you are talking about topic modeling, you don't need any punctuation, right? You just need the words. So doing topic modeling or keywords extraction, you may need to remove punctuation. Using back of words or TF-IDF features, like the counter class that we used, that is an example of back of words. So in that case, you may need to remove punctuation. For example, when you come to this, where is it? When you scroll, oh, maybe this one is the cleaned one. Where is what I want to show? And before this. I think it appears when we pass the document before pre-processing, right? So you see some of the commas, some of the inverted, some of the bracket, they are all appearing. When you are looking for topics, what business do you have with brackets? I guess you don't have any business with that, right? So depending on the task at hand, that will determine what you should do, right? Then basic text classification. So if you want to just classify your text, remove punctuation. Search and indexing. So for example, if you look at the index at the back of your book, you will not see punctuation marks part of that index. So if you are doing any indexing, remove punctuation. But you should keep punctuation when you want to do sentiment or emotion analysis. For example, happy with double exclamation mark is more happier than happy without exclamation mark. Do you agree with me? Let me know in the chat. Happy with double exclamation mark is happier than happy without exclamation mark. Okay. Jessica is agreeing with me. Okay. All right. So when you are doing sentiment analysis and you go and remove that exclamation mark, you are reducing the sentiment, all right? Then we have also seen in those examples I opened the class with, you see that by simply changing the punctuation, you are changing the meaning. So in that case, you may not actually drive the actual meaning. Training machine translation models. This one, don't go and remove it. All right. Performing name entity recognition or syntax parsing. Running summarization, don't remove the punctuation marks. So numbers also, similarly applicable to numbers. There are some situations you need to remove numbers, some situations you don't need to remove numbers. All right. Then also we have what we call special characters. So there are some situations you may need to remove special characters. In some situations, you need to leave special characters. All right. So an example of situation where you may need to leave special characters, like financial text. If you go and remove pounds, dollar sign, and naira sign, you are on your own. The model will be confused whether the number you are presenting to it is in dollars or in pounds or in Kenyan shilling. All right. So another thing that we can do, for example, in tweets, like answers is one tweet that, it's one tweet that was raining in Nigeria sometime. Answers was a hashtag in Nigeria. So if this is your text and you want to extract this pattern, so for example, if you want to extract hashtags, right? How do you extract them? So your pattern will be hash, all right? So if you pass the pattern and you pass this and you pass the text, you see you are able to extract the hashtag. All right, then next we have what we call tokenization. Remember, we said tokenization is the process of breaking text into smaller units called tokens. These tokens are usually words. Sometimes they can be smaller than words, but most of the times they are words. They can also be subwords, and they can be sentences, depending on the task. Tokenization is one of the first steps in NLP pre-processing. Why do you need to tokenize? Well, we as humans, we understand passages word by word, right? So similarly, machines need to understand them word by word. Tokenization simplifies text processing. They enable feature extraction, support NLP tags, right? So you remember in that document, when I remove the pre-processing, that's the tokenization. What happened, instead of counting each word, the counter class was counting each alphabet, which is not correct. So that's why we need tokenization. So for example, if you have text, I love NLP, your tokens will now be I love NLP. That's a list of all characters, of all words in this. So this is word tokenization. In that case, you are splitting your document into words, and your tokens will now be in the form of a list. Then we also have sentence tokenization. So sometimes you may want to understand passage from the sentence perspective, right? So when you want to pass that to machine, you also do sentence tokenization. So if you say, I love NLP, it is amazing, right? So your tokens will now be, I love NLP, comma, it is amazing. That's another one. Then now we have one simple exercise. I love NLP, it is amazing. Now, how do you extract these tokens? So when you say what tokenize, that's extracting the words. So the tokens will now be I love NLP, like that. So you see, these are the words, right? So that's just the token. All the token we're talking about, that's it. So, but if you want to do sentence tokenize, you say send tokenize. So we have also import all of this from lltk.tokenize. So when you do send tokenize, now your tokens will now be sentences, right? So I love NLP, it is amazing. Tokenization is essential, right? So if you do sentence tokenize on this, I love NLP, it is amazing. Tokenization is essential. So these are units that you can pass to your model in order to make meaning out of it. Then we also have what we call stemming and lemmatization, right? So what is stemming? Sometimes like running, runs, runner, they can have similar meaning, right? I mean, they have similar roots or the same root. Running, runner, runs. All their roots is what? Run. So given a word, how do you go to the root? Because sometimes the variations may not give different meanings. So we want a situation whereby we revert back to the root, so that if we are counting everything, all these running, runs, and runner will be the same thing. All right. So you can use what we call stemming. We have this Porter stemmer class that can help us with that. So if you pass these words or this list to it, and you do your list comprehension, then you can see run. So running, the root is run. Runs, the root is run. However, runner is what? It's not converted to run. Why? Because this stemma is having some sense, right? So while running and runs, they are all verbs, so they will have the same meaning. But runner is a noun, so it will not have the same meaning with this. However, it is also producing some words that are not in English, like easily. This one is not English word. But fairness and fair, well, that is the root, right? Then we also have what we call lemmatization. Okay, because of time, I'll rush this. So this one can produce words that are not in English, which is not making much sense. But lemmatization will ensure that it is producing words that are English. So when you run that, when you lemmatize, what happened? Like run, runner. Now, instead of easily with Li at the end, you are still having easily, right? Although it was not able to revert back to easy, but at least it is producing something that is in English. And with all honesty, this fairness and fair, they may not have the same root. So that's why lemmatization is more intelligent than this. So we also have another NLP task like feature extraction. So feature extraction in NLP is the process of transforming raw text data into numerical format that machine learning algorithms can process. So because of time, we will not go through this, but I trust that, oh, it's not even much, but I trust that you can actually go through it and make meaning out of it. All right. And I guess I have addressed your questions during our interaction. Now, before I hand it over to John, I want to ask you, how many of you have portfolio projects? If you have one, put one. If you have, or how many portfolio projects you have? So put the number in the chat. If you don't have any, please put 0. So let me see. 0. Okay, Juliet is saying 0. 0. Any other one? So I have one plea for you. Please and please. I don't know whether I should kneel down and beg you in the African way. Please and please. Although I know learning can be challenging, but if you have the time, please try as much as possible to build those personal projects. They are going to help you with, 1, understanding the concept better, and 2, there are also signals to employer that you are good to go, right? Because employers want to see things that you have built. So when you get this document, when you click this, it can land you to our guide for portfolio project that we have for you, and you can follow it and make yourself comfortable. Thank you very much, and thank you, Kayode, and thank you all for participating. Thank you, Yvonne, Hendricks, Edu, Victory, Juliet, Jessica, Mike, all those that I called their names, and even those that I didn't call their name. Thank you very much for attending and participating, and I'll hand it over to John. Please, John, you can launch the poll and you can take over the presentation. Thank you very much.
Thank you. Buhari, I think before you go, kindly launch the poll. I think I don't have host privileges. Thank
All
you
right.
for that. Oh, okay, thank you. Yeah, so even as we get to the last part of this session, we want to go to the learning and technical support. Get me to the next slide. Thank you. We have the poll. Kindly let us fill in the poll. Let us get to interact with the poll so that we can have some better outcome for the next PPL sessions that we are going to be hosting. Okay, so let's go to the learning and technical support. The first place where we want to talk about is Ask the ALX Data Program Team. This is the eHub community space where you can ask any program or content-related questions. And as we always say, is kindly use this space for this purpose, because most of you always come there to say hi to your peers and also to just give some unrelated content on that platform. So anything that is program or content related, you can always ask there, and you're going to get all the data team helping you, and also the technical mentors will always be there. The next one is the fresh desk. This is where this is your go-to space for all program support, anything that you have issue with, including probably payment or any other thing. You can always raise a ticket in there. Then lastly, we have the answer base. This is a channel specially dedicated for you to ask and get answers to complex content questions. So we go to the next steps. Your next assessment is due Tuesday, 9th June at 9:59 p.m. GMT. That will be the NLP theory test. Also find your session recordings and resources on the machine learning -4 2026 program hub. So anything that we do here, in most cases, we normally do post it there so that we can have all of you having the recordings and also having the materials that we used on the PPL sessions. Remember, you're not alone in the community. Engage with your squads, ask for clarity, and post your wins, challenges, and new insights on your squad spaces. Apart from that, we were happy to have you here, and looking forward to the next session. And for now, we want to say goodbye and see you next week on a Wednesday. Let's continue doing hard things and have a lovely week.
It's the kids, baby. Masikhohlwe ngenkinga sekukubalisela masikhuphula imizwa sukumisa umzimba masikhohlwe ngenkinga sekukubalisela masikhuphula imizwa sukumisa umzimba Koma sava, koma savana na, aye sava, na.
Koma sava, koma sava, koma sava, koma sava.